Welcome to Dramani Online Mathematics. Today we are going to look at least squared approximation. We have talked about that already, but the one we did was the discrete case. This time around we're going to look at the continuous case. Is that alright? So now looking at this one, the continuous case, we have, but the aim here is to what? Minimize the error. Minimize the error and fit a particular line. So for us to be able to minimize the error, we use the integration starting from a to b f of x minus p of x dx. I hope you have seen this formula before when you were dealing with the discrete. Just that for the discrete, we're looking at the summation of it, but here we want to look at the error how we can minimize the error. So we looked at the integration part of it, that is the area. Okay, so now looking at this particular thing, the f of x is the continuous function. Then the p of x is the approximation function. Is that okay? Now, if you remember when we were looking at the least square for the discrete, we said that we should let y to be equal to f of what? X. And also the polynomial or the approximation function is also written as a0 plus a1x plus a2x squared plus, so you see that the a2 is increasing, the x2 is what? Increasing. It means that this side is going to be a k x k. You can also differentiate by writing here maybe n, using n to represent, depending on you. So per what I have here, I can substitute the value of f of x and that of p of x into this. So it means I have x to be equals to the integral starting from a to b. My f of x is now y minus p of x is now a0 plus a1x plus a2x squared plus a k x k, and this is what? Dx. So this is what we have. Now let's look at how we can use this particular thing to fit a line. So let's look at this example. Equals to 1. So this is the question. How do you solve this question? They have given us the interval. So looking at this, a and b, that's our interval. So the a is the lower limit, b is the upper limit. So if you want to start solving this, you have to be able to write down the parameters given. You know the formula is given as s equals integral starting from a to b f of x minus p of x all squared dx. Okay, this is the formula. So looking at this, our y or f of x is what? Root x. Now you have to say that you have to let p of x to be equals to Now, in the question, you are talking about what? A line. So you know the general equation of a line, and it is ax plus what? B. So in place of the px, that will give us the approximation function. That's the line given, and the y has already been given to you. So from here, I have my x equals, starting from, so my a is 0, my b is 1. I have 0 towards 1. Y is what? Root x minus p of x is now ax plus what? B, all squared dx. Now at this particular point, this is root x minus ax plus b all squared. So it means that you have to expand this bracket. So how do you expand this bracket? I can write this one as from 0 to 1 root of x minus ax minus b all squared dx. Alright, so looking at this particular point, let's try to expand it. So you know that my x equals the integral starting from 0 to 1. So if I expand this one, this will give me this. I'm going straight. You can decide to open this, rewrite this one 2 times, root x minus ax minus b in one bracket, another bracket, then repeat it and expand it yourself. You can do it. So looking at it, if I expand this, I'm going to have x minus 2ax to the power 3 over 2 minus 2bx to the power half plus a squared x squared plus 2abx plus b squared, then we close our bracket, dx. So when you're expanding this, change the root sign to x to the power what? Half. So you change it to exponential one, to x to the power half, then you expand. So now after getting whatever we have here, remember this is a definite integral, so you can easily what? Integrate this. Is that okay? But remember you are integrating this one with respect to what? X. So if we are integrating this with respect to x, then I'm going to have my x is going to be, if I integrate this one, this will give me x squared over 2 minus, if I integrate this one, that will give me 4 over 5 ax to the power 5 over 2. Because when we are integrating, we add 1 to this. This will give us 3 over 2 plus 1. So this will end up giving us 5 over 2. Okay? But you divide by this 5 over 2. And that 2 here will multiply whatever that is top here. Already 2 is there, so that will be 4. So don't be confused. You can do it on your own and see whether what I'm saying is correct. Now let's check at this one too. If you differentiate this, this one will give us 1 over 2 plus 1, that will be 3 over 2. So the 2 can multiply this, that will give us minus 4bx to the power 3 over 2 over 3. Then plus, you get to this side, this is just x squared, so if I differentiate, integrate x squared, I'll have x to the power 3 over 3, but a squared is already there, plus This will give us 2ab x squared over what? 2. But this 2 will cancel this 2. They have b squared. This is a constant, and if you integrate the constant, just attach the operator to it. So this is what we have. Remember, I start from 0 to 1. 0 to 1. So now my x now becomes, I'm going to substitute the upper limit into this. So if I put 1 here, I'll have 1 over 2 minus, if I put 1 here, still it will give me 4 over 5a minus 4 over 3b plus a squared over 3 plus a here, that will give me, and these two and that 2 will cancel, leaving ab plus this one too will be 1, so this will give us b squared. Is that okay? So now this is what we have. We are saying, what you have to understand at this particular point is that for you to minimize the error, then the partial derivative of this s with respect to either a or the partial derivative with this s with respect to either b should give us what? 0. So this and that, either this one give us 0 or that. Any of them or both of them have to give us 0. In fact, both of them have to give us 0. So looking at this, so now let me take the partial derivative with respect to a. So delta s delta a will be, if I differentiate half, I'll get 0 because it's constant. In fact, everything will be constant except a. So this one will give me 0. This is a, so if I differentiate the s with respect to a, I'll get 1. So this side will give me negative 4 over 5. Then this side too, because the b is constant, they are taken partially with a, so the b will be constant, so this side also go to 0. Now this side is a squared, so if I differentiate a squared, that will give me 2a over 3. Is that okay? Then let's also look at this. If I differentiate with respect to a, this one will be 1, leaving b, and this one will go to 0. So equate this one towards 0. So it means that 2a over 3 plus b is equals to 4 over 5. You name this one as equation 1. Now let's move on to the next one. That will be the delta s delta b. So for you to be able to minimize the error, then their partial with respect to a and b should be what? 0. So if I take the second one, I'm going to differentiate partially with b. This will go to 0 because this constant. A here will also go to 0. Now this b will be 1. So I have negative 4 over 3. Then this side will go to 0. This b here will be 1, leaving a. So plus a. And this b give us 2b. And this is equals to 0. So at the end we are having a plus 2b is equals to 4 over 3. So we name this one as equation 2. So if you have something like this, you have to solve it simultaneously. So solving equation 1 and equation 2 simultaneously, we have our a to be 4 over 5, and our b is 4 over 15. So now, after getting this, in fact, we wanted to, the line that I quoted for you, the p of x, which was ax plus b. No, this is a line, so I can also write it as y equals ax plus b. Now this one, the aim was to find a and b. Now we have our a and b. Therefore, the least square approximation is y equals, so our a was 4/5 x plus b was 4/15, and that is how you can get our answer. So anytime they give it to you, you make sure that you take the square of it, expand it, and take the partial with respect to a and b, equate them to 0, and use it and solve for simultaneous equation so that you can get your a and b. Then go back and substitute into the line that you quoted from the beginning. Okay, we can solve this one another way. So let's look at the alternative way. So I'm writing what we have straight here, 0 to 1 root x minus ax plus b all squared dx. Okay, let's assume we have this. The first thing, or the first one we did, we decided to expand this one. This time around, I can decide not to expand it. I can go straight. We know I can take the partial derivative with respect to a here straight from this. So if I'm differentiating it, this is a composite function. So I have to differentiate the whole function first, which will give me 2 outside 0 to 1 root of what? X minus ax plus b ax minus b times, then I'll differentiate the inside. If I differentiate the inside, because it's with respect to a, with x will be 0, b will be 0. And if you differentiate a, it will give you what? 1. So 1 times x will be what? X. Then bring your dx. And you are saying that this one is equal to what? 0. So if you look at this one, there will be negative here because there's negative affecting this. So if you bring it out, that's how it's going to be. I can divide through by negative 2. If I do that, it will leave with 0 to 1 root of x minus ax plus b dx. You know, this one I can bring the x here. It's the same thing. It's equal to what? 0. Now at this particular point, I can multiply this x through. Is that okay? I can multiply this x through. But let me leave it here and deal with the b. So partial of b is also going to be 2 starting from 0 to 1. Then I will maintain what is inside root x minus ax plus b times, now I'm going to differentiate with respect to b partially. So this and that will be 0, so b will give us what? 1. But there will be negative affecting this, so let me bring it in front of this. dx. And you're saying this is what? 0. So it means that if I divide through by negative 2, then I'll have, starting from 0 to 1, root of x minus ax plus b dx. Because this one, if I bring it here, 1 time this will give us the same thing. It's equals to 0. So I have these two. So I'm now going to, so the first one, there's x here. And know that square roots of x can be written as x to the power half. So I'm going to multiply through by x. Okay, so I have the integral starting from 0 to 1. X times x to the power half, so it will be like x times this times that. This is power 1. 1 plus half, because if the base are the same, add the powers. 1 plus half will give you 3 over 2. So that will be x to the power 3 over 2. Is that okay? Now this x is multiplying this, and that will give you negative ax squared. And this x is also multiplying this b, that will be negative bx. Is that okay? Dx is equals to 0. So now let me integrate this. When I'm integrating, I'm adding 1 to this, divided by whatever I'll get up there. So that will give us x to the power 5 over 2 over 5 minus this one will give us ax squared, ax cube over 3 minus bx squared over 2. Starting from 0 to 1 is equals to 0. So let's substitute the limits in. If I put 1 here, I have 2 over 5 minus a over 3 minus b over 2 equals 0. I don't bring the 0 or substitute the 0 because if I put 0 there, I'll get everything to be 0. So that's why I'm just leaving this one. So if you look at this, I have negative a over 3 minus b over 2 is equals to negative 5 over 2. You can multiply through by negative to get a over 3 plus b over 2 equals to 5 over 2. Name this one equation 1. Then also, let's move to the b. Already the b, we have nothing to multiply there. But if you look at this one, it's x to the power half. So if I'm integrating straight from here. So x to the power half, if I'm to integrate, I'll just add 1 to it. That will be 3 over 2. So now let's look. So if I integrate this one, I'm going to have 2x to the power 3 over 2 over 3. But this one will be 3 over 2 over 3 over 2. So that 2 can come here. Then minus ax. If I integrate with respect to x, this will give me minus ax squared over 2. And negative sign is here. So if I integrate with respect to x, the b is treated as constant, so it will be negative bx. Sum from 0 to 1 is equals to this. So if I substitute the value of 1 there, I'm going to have 2 over 3 minus a over 2 minus b equals 0. Put 0 there, you get everything to be 0. So if I bring this one there, I'm going to have a over 2 plus b is equals to 2 over 3. Alright, let's name this one equation 2. So now we have equation 1, we have equation 2, so we have to solve this one simultaneously. So solving equation 1 and equation 2, simultaneously, we have our a to be, you get the same answer, a to be 4 over 5 and b to be 4 over 15. But you know our line was equals to y equals ax plus what? B. So y equals a is now 4 over 5x plus b is 4 over what? 15. So this is what we are looking for. Okay, now let's look at this example, example 2. The first question we saw was a line. This one is what? Quadratic. So the first you have to know that quadratic is in the form of ax squared plus bx plus what? C. Is that okay? It means that with this, you have to take the partial with respect to A, partial with respect to B, then partial with respect to what? C. Is that okay? So that's what you are going to do for now. Here, our x is going to start from 0 to 1. The interval was 0 to 1. Our y is root x minus, so our p of x is what is given, which is a x squared plus bx plus c dx, and there's a square here. I'm going with the second approach that I use, okay? So let's go with that. So first I'm going to find partial with respect to a. So looking at this, the 2 will come here, starting from 0 to 1. You know, this negative is affecting, so let me bring the negative there. And repeat whatever that is here, root x minus ax squared plus bx plus c dx. Alright. Let me differentiate the inside. We are differentiating it with respect to a. This will be 0, this will be 0, this will be 0 because there's no a here, no a here, no a here. So you consider this. If you look at this one, the a here is just a, not a squared. So if I differentiate a, I'll get 1. 1 times x squared will give me x squared. Then I'll bring my dx. And you are saying this is equals to what? 0. Now let's also look at with b. So partially with b, negative 2 is coming out from 0 to 1, repeating whatever that is here, minus ax squared plus bx plus c. Is that okay? Then here I'm considering the b, so root x will be constant, a will be constant, c will be constant, so only this. If I differentiate b, I'll get 1 times x is x dx equals to 0. Then you also move to the c. So looking at the c, I have negative 2 starting from 0 to 1, repeating what is here, root x minus ax squared plus bx plus c. Then I'm differentiating with respect to c, so this will be constant, all goes to 0. So let me see, if you differentiate c, you get 1 dx, and this is also equals to what? 0. Alright, now let's come back to the one with respect to a, the partial with respect to a. You see, I can multiply through by the x squared. But this root x, you have to change it to what? X to the power half, so that you can do the multiplication. So let me do that. Integral from 0 to 1, x squared times x to the power half. That will give us x squared times x to the power half. I have x to the power 2 plus 1 over 2. 2 and 2 plus 1, 5. So 5 over 2. So the first side, remember if I divide through by the negative 2, all the negative 2 will go. Okay. So the first side is going to give us x to the power 5 over 2. Then x squared, remember there's negative here, so x squared 2 multiplying this will give us negative ax to the power 4. X squared times this will give us negative bx cubed. X squared times c, we are negative cx squared. And this is the x. And it's equals to what? 0. So let's integrate it. If I integrate this one, I'm adding 1 to this. So I'm going to have 2x to the power 7 over 2, all over 7. Minus, I'm adding 1 to this, so I have ax to the power 5 over 5. Minus bx to the power 4 over 4. Minus cx squared x cubed over 3 is equals to 0. Now starting from 0 to 1. So let's substitute the limits. If I put 1 here, I have 2 over 7 minus a over 5 minus b over 4 minus c over 3 equals 0. If I send the negative 2 over 7 here, taking the additive inverse, it will become negative here. And there's negative throughout, so I can make it positive. A over 5 plus b over 4 plus c over 3 equals 2 over 7. Equation 1. Now let's also look at the next one. The partial derivative with respect to b. That one too is having x multiplying through. But this x here is roots x, that's x to the power half. So x to the power half plus 1. Because if I multiply it, that will be the same base, so I just add their power. This is power 1. This will give us 3 over 2. So I have integral starting from 0 to 1. X to the power 3 over 2. Then this x is then multiplying this by this negative sign, so I have negative ax cubed. Then this x is multiplying this, there's negative sign, so negative bx squared. This multiplying this, that will be negative cx. Alright. Equals to 0. So let's try to integrate this. If I integrate, if I add this 1 to this, it will be 5 over 2. So 2x to the power 5 over 2 over 5 minus ax to the power 4 over 4 minus bx to the power 3 over 3 minus cx squared over 2 from 0 to 1 equals 0. So I'm going to have 2 over 5 minus a over 4 minus b over 3 minus c over 2 is equal to 0. I've just substituted the value of 1 here. For the 0, everything will go to 0, so I don't worry myself over it. Plus b over 3 plus c over 2 is equals to 2 over 5. Name this one equation 2. Now let's move to the last one. But the last one is very simple because it's multiplying through by 1. So 1 by this, it will be the same thing. If I divide through by the negative 2, this negative 2 will go. So I have to integrate it straight. Remember, it's x to the power half. So if I integrate x to the power half, it's going to give me x to the power 3 over 2 over 3 like this, minus ax cubed over 3 minus bx squared over 2 minus cx is equals to 0. Starting from 0 to 1. So substitute the value of the limit. We have 2 over 3 minus a over 3 minus b over 2 minus c equals 0. So it means that a over 3 plus b over 2 plus c is equals to 2 over 3, equation 3. Now when we get to this point, we have to solve this one simultaneously. We have equation 1, we have equation 2, we have equation 3. So we need to solve it simultaneously. How do we solve this one simultaneously? It's very simple. You can use your calculator to do it. Very simple, right? Or you can decide to go through the procedure to solve it. That one depends on you. Depends on you. So now let's check. Let me use my calculator to do that. So if I use the calculator, well, I have my a to be negative 4 over 7, b to be 48 over 35, then c to be 6 over 35. So this is what we have. Therefore, you know, the line was y equals ax squared, so negative 4 over 7x squared plus, let me rewrite the line for you to see, y is equals to a x squared plus bx plus c. So y equals, my a is now negative 4 over 7 x squared plus 48 over 35 x plus 6 over 35. So this will be our final answer. I think this will help you a lot. Try to share it to your friends so that they can also subscribe and learn with us. Thank you very much.